Welcome to another video. This is the syllabus of GATE examination. In this video I will cover this topic, divergence. Okay, I have already explained the del of f, where del is applied for a scalar function of f, where f is of f. Suppose f, for example, f is x cube y squared z. So in this way f is a scalar function of x, y, z. What about if f is a vector quantity? So if f is a vector quantity and if you perform similar action, you require to perform divergence of function f. So this is the f, which is a vector quantity. It is having, you can write f is it as f of x, y, z, I, because f is a vector quantity, so it must have I, j and k vector, unit vector. So f x, y, z, and another function phi x, y, z, and another third function, suppose theta x, y, z, k. So you suppose f is vector, I, j and k is the unit vector, and multiplication of it is a function of x, y, z. For j there is another function of x, y, z, and for k there is another function of x, y, z. So if f is a vector quantity, if you want to apply similar to del f, then you require to find out the divergence of f, div of f, div of f. So whenever anyone says div, you must ensure that this should be a vector quantity. You can only calculate the divergence of vector quantity. So divergence of f is equivalent to del of f, but f is a vector quantity, so you require to perform dot multiplication of del and f. Del is also a vector. You can treat del as a vector quantity. And what is the meaning of del? Del is del by del x I, del by del y j, and del by del z k. It is a vector quantity, and dot multiplication it with vector f. Vector f, short form of function of x, y, z is fi, short form of phi x, y, z is phi, and short form of theta x, y, z is theta. So here is two vector. First vector is this, another vector is this. So if you dot multiply, if you dot multiply two vector, it will be always equal to multiplication of I plus multiplication of j and plus multiplication of k. So it is equal to del f by del x plus del phi by del y plus del theta by del z. So divergence of f is equal to del f by del x plus del phi by del phi plus del theta by del z. That means if f is a vector quantity, where it is, if f is represented by like this, then if you want to calculate the divergence of f, you just require one step, that is you differentiate this component with respect to x, treating other variable as constant, add it with differentiate this with respect to y, treating other variable as constant, and add it with differentiate this function with respect to z and treat other variables as constant. You will get the value of divergence of f. So this is the important result. You must remember it. Suppose here is the example of a function where you require to find out the divergence of that function. Suppose this is a function f Suppose this is a function f where coefficient of I is 4x square y, coefficient of j is 5xy cube, and coefficient of k is 3xy z square, and you are required to find out the divergence of f. So divergence of f is, so find out the what is the first function. This is the first function f. This is another function for coefficient of j. This is, you can treat it as phi, and this is the third function, which is coefficient of k. It is you can write it as theta. So in earlier I have explained that divergence of f is del f by del x. That means you have to differentiate f, coefficient of I, with respect to x. So if you differentiate this with respect to x, you will get 8x y plus differentiate phi with respect to y. So you will get 15 x y square, and plus differentiate theta with respect to z, you will get 6x y z. So this is the function of divergence of f. If you put the value of x is equal to 3, y is equal to 2, and z is equal to 1, you will get 48 plus 180 plus 36, that is equal to 264. So divergence of f is 264 at this point. If point is different, divergence of f value will be different. So divergence of f, value of divergence of f is dependent on position x, y, and z. So what is the physical interpretation of divergence of any function? Suppose this is a pipe where water is flowing into it, and at any point at velocity of particle is v, which is having three component along x, along y, and z. So v is having three component. V is a vector. It is having three component: vxi and vy, component of v along y, vector quantity j, plus vz k. So v is having three component at any place. If you find out the divergence of f, it will give a value. That value is basically rate of production of the amount at that point. Suppose this is only a pipe where same amount of water is flowing. Suppose Q is the amount of water going to this, and same amount of water is coming out. So there is no production of any quantity of liquid at this point. So divergence of V will be 0 for all the points. So divergence of V is equal to 0. It is called as solenoidal vector function. If this is satisfied, divergence of V is 0, then V is called solenoidal vector function. So in the earlier slides I have shown that for a vector quantity you can get the some values of divergence of V. If there is some value, suppose the divergence of V is something like 2. If divergence of V is 2, that means at that point liquid is produced, means generated at a rate of 2 meter cube per second SI units. So I am repeating once again. Whenever you require to find out the divergence of a function f. First, you ensure that f is a vector quantity in the form of f of x, y, z, I. Similarly, another function, suppose phi, j, third function, that is theta, k, and what do you require to find out? Div. If you require to find out the div of this function, you differentiate this first function with respect to x only, differentiate the second function with respect to y, and differentiate third function with respect to z. You will get and add all, you will get the divergence of f. That means del f by del x plus del phi by del y and del theta by del z. If x, y, z value is given as a point value, then you just put the values of x, y, z, and you will get the exact value of divergence of f at that particular point. That's it.